morning, everybody. Thanks for joining. So a little bit about me. I'm Dhakne. I'm based in San Jose, California. I've been working with Confluent for more than 4+ years.
Good morning, everyone. My name is James Nguyen. I'm an architect with Microsoft. I'm based out of Seattle, focused in AI and ML, particularly in Gen AI.
So with Confluent, we are in the mission to create this new category, which is like, data streaming. So which basically sets your data in motion. In this flow chart, you see that, your data is coming in from different sources, but then all this gets fed into Confluent, and then we can process those event streams in real time. So with Confluent Cloud, what we have done is that we have completely built this, we have completely re-architected open source Apache Kafka. So, and when we created this service, we created with 3 core pillars: that it has to be cloud native, it is complete, and it is everywhere. And as you can see, the core of the Confluent Cloud is Apache Kafka, but open source, but you cannot run an open enterprise-grade application just on the open source product. So you need enterprise-grade features. So we have built these features right from developer to operator to architect to the executives, so that there is something for everybody. So as we set out with the goal to set the data in motion for the enterprises, so we want to be the central nervous system for your data. So all your sources will publish their events into Kafka, and then there'll be consumers on the other side so that they can consume those events. So what we have done so far and how is our recognition? So we are Microsoft Commercial Marketplace Partner of the Year. We are the original creators of Apache Kafka. We internally on Confluent Cloud, we run 30,000+ clusters, and the number is growing every day. And in terms of Kafka experience, our technology has only one product, that is Apache Kafka. We have 1 million hours of Kafka experience. Okay, so then the question comes that, hey, how is Confluent actually helping in this scenario where somebody wants to build a real-time copilot? The reason is that a lot of these real-time applications that typically we interact with, they are suboptimal. It doesn't really gives you the benefit of giving the real information. You have to ultimately end up talking to an agent. Then you can get what typically you want. To build real-time copilots, the Confluent Cloud is a key thing there, which brings your real-time data, and it can hand it down that data to the rest of the Azure Core Services. So with that, I will hand this out for the rest of the presentation to James, and I'll stop sharing, and then James can take over.
So there are a few steps that the first step is the capabilities bringing in from the large language model like Azure OpenAI. And then later on, we talk about the necessary infrastructures for you to surface streaming real-time data for your Copilot. So in terms of the large language models, the LLM that we created have the ability to execute transaction, right, or function calling, let me call that that way, which is available in the model version 0613 and 1106. So the step to do this, first of all, start with the large language model itself, and how do I go about enable my chatbot, my intelligent agent, to be able to act as a human in a way that, okay, number one, it has some sort of follow some business process. Number two, it is aware of the tools that are available for the Copilot to use. And then number three, how do you go about helping the LLM itself execute the function calling flow, right? So these are the 3 points that I mentioned here to be part of the work that you need to do in your OpenAI model, in your large language model, right? All right, so let's zoom in the step number one. Like, what do I mean by define the flow, define the expected behavior? What do I mean by that? So I think it is best to illustrate that with the example like this. So look at the step number one. What do you mean by the business flow and the expected behavior? So this is nothing but it's just the think about this as a training material for your staff, right? So in this case, think of the step that you need to train your customer support agent for a airline company, right? In this case, that it is Maya, an airline customer agent, helping customer with question and request about their flight, right? And then you see that there are detailed steps of, okay, how to handle when it comes to question, how to handle when it comes to rebook the flight, changing the flight, right? So that's a detailed business process, and it is defined by the very natural language as if we're gonna give this to a human agent. Very interesting, right? And remember a few things here. The dimension of the tool. For example, when you are asked to answer a question about a general knowledge question, then use a search tool. When you ask to check the flight status, then use the flight status API, right? Very fairly, very easy to understand. And then, so you define this in the system message for our Azure OpenAI large language model. And the same step, you need to define the function specification. In this case, the example is the search knowledge base tool, which is the tool that the agent gonna use when it needs to answer the question from the user for general thing like, okay, what if I need to check more bags? What the price, what the cost for example, for changing the flight and so on. So in this case, to use the tools, we also need to define not only the tool's name, but also the parameters. And this is an excellent way to force the LLM to produce, in this case, the search query, right? It can be easy like a free-form text search query, or it can be a complex search query like a SQL query, right? Very interesting on this. And of course, you're going to have the other traditional APIs like, okay, I need to book the flight, so you need to have the flight ID and so on, which you're going to see in the demo very soon, okay? But hopefully this is going to give you an idea of, okay, this is the specification of the function that the model you need to do. Okay, so having implemented those two steps, now you need to, in your application, right? In your application, you need to implement the function calling flow. So the LLM, remember, it's just the machine learning model. It cannot do physically do stuff for you, right? You have to. It just give you, okay, hey, this is a function to call, execute for me. So you need to implement this flow. This is the flow, right? So you need to check if the models want to use the function, and then it can output for you the names and the parameters when the situation requires that it should call the function. For example, when user asks question, for example, when user asks you to ask the model to book a flight, right? So the model gonna feel the need to, okay, hey, I need to execute this transaction. So it's gonna give you the function names and parameters. Your job or your application's job is to have it execute the function and then get the output from the result and then send it to the LLM, right? And then LLM can do the response, okay? So this flow, you need to implement this in your application. All right, so we have covered the step that we need to do in the large language model side to enable intelligent function calling capabilities. But function calling LLM alone are not enough to implement an application on top of streaming data. There are things that we need to enable from the platform. That's why we partner with Confluent today to bring you the end-to-end architectures to enable these entire solutions. So this is the architectures, the underlying architecture that empower the solution of Copilot on top of streaming data, right? So on the top, you see that they're going to be various kind of real-time events in the real-time application, traditional real-time application, right? So we have, for example, weather updates, airline policy changes, right? So they change the flight policy, flight update. You see tons of different kind of sources like this with a very high volume like this. Yeah, and luckily we have Confluent Cloud platform, the best streaming platform out there to ingest the data and then to process data in motion for us, right? And this is gonna help us to have the low latency ingestion transformation of all the data. So something unique to the Copilot scenario is that, okay, for example, when you need to let's say perform the question answer on unstructured data, then you have to create the embedding, right? So search it up if you are not familiar with this, but it is ability for the LLM to, or for the search engine to retrieve the relevant context when it comes to the question. So for this, we have to have a special type of transformation, which is embedding, but we need to do this in real time, right? That's why you see the Azure function here that respond to the trigger from the Confluent Kafka, and it can process, it can convert data, it can convert the text data into the embedding format, and then ingest data into cognitive search. On the other end, for the traditional structured data, we have the connector between our Azure Cosmos DB, our flagship product for global distributed transaction data platform that ingest directly from Confluent after all the streaming transformation that you normally see into the Cosmos DB, right? And then once you have the structured data in Cosmos DB, once you have the unstructured data and other data that you want to make available for the search in Azure Cognitive Search, and remember, all these are done in real time. And then on top of this, now we're going to put on, okay, this is my Copilot, this is my Azure web app on top, and this Copilot gonna provide the service to your end user, right? With all the feature that I mentioned earlier, function calling, the ability to intelligently understand the user question and execute transaction. And in this case, Copilot gonna execute against Cosmos DB. It can execute against Azure Cognitive Search. All right, so to make the conversation interesting, so we have built a real-time demo, a Copilot demo on this very architecture for you today. So the demo is about a flight Copilot, a personal flight Copilot that helps customer the tasks of everything from flight status update, checking, airline policy question answering, and flight rebooking. This is Maya, which is the name of our ally customer specialist or Copilot, and she has the access to the flight booking system. She has access to my data, so she knows my name, John Doe, and she can. I'm gonna ask her to perform some of the tasks, right? This including some of the real-time update. Okay, the first of all, I'm gonna ask her, hey, can you retrieve my flight detail? So for this, she's gonna make a query to my Cosmos DB system to retrieve my flight details that I already booked before, right? Okay, so she retrieved my flight, and I'm doing my American flight, flying from JFK to LA, right? So so I'm gonna first of all I'm gonna check. Okay, hey, can you check? Okay, I'm gonna ask question: is my flight still on time? I'm gonna ask this question, and again, this is all about real time, right? So you can execute a search query, like an API query to my system, and then okay, it's all good. Before I do this, I just want to log in some of the backend system before we go. Okay, good. So now the scenario next I want to demo is like, what if, let's say, at this very moment, some weather change event happen that gonna impact my flight, and it become like it delay my flight, right? So I'm gonna simulate this by, remember we have built this on top of Confluent Cloud at the platform for streaming. So I'm gonna do next is I'm gonna issue a simulated event. Okay, that the change in the weather that's gonna delay my flight. So I'm gonna do that by sending an event to my Confluent Kafka and see what's gonna change after this. Okay, let's do some more thing interesting. Let's do something. Okay, I like to explore option of fly. Taking an earlier flight. What option do I have? So in this case, she can perform. So I just want to showcase that we're going to perform some of the more complex transaction behind the scene. All right. So for example, I like to see the option of available flight. Then okay, I like to go with option 3. So in this case, it is a complex transaction because it involves calling to multiple surrounding system, multiple APIs. And you know that changing the flight in the airline is not easy, right? You have to check a ton of things. So in this case, it is also the ability for the Copilot to intelligently follow a business process. So let's say in this case, I like to option 3, and she said that changing a flight would cost additional $80. Right? So she's gonna need to confirm with me. Okay, yes, please go ahead.
So here, what we see is that once the application once we simulated the weather update application ingests that data into the flight status topic, and then that topic data, as we just saw in the message, then that is consumed by the Azure function, and then that is consumed by rest of the OpenAI services, And that's how the Copilot understands that, okay, I see that there is a weather update that has come in and that has impacted John Doe's flight. And this is very key that Confluent is the conduit here for the real-time data. And then, the Copilot that we see here is actually more contextual, more effective, and is to the point, and it is able to handle like this multiple calls that have to go across like different services. And then we can see the benefit of, having this Copilot where we can do when we can see the real-time updates.
So one thing that I forgot is I forgot to set the user ID for the authentication to the Cosmos DB. So we need to cancel this transaction. But I'm going to show another example of of the real-time update on the policy. Yeah, can you retrieve my flight detail? So I'm gonna next demo is gonna be about like the change of the policy, right? So let's say I'm gonna ask a question of what's the additional cost of checking additional back, right? I'm gonna ask this. It's a policy question, right? So it's not transaction anymore. And I'm going to show the power of also the real-time update in terms of the unstructured data. So first you see here, you're going to say that you're going to, right. So this is the answer. This is the current answer. 150, right? So 150 for the additional back. So I'm going to go ahead by adding another chain. Let's say you see here the policy. This is the policy that I want to update. I want to update it, make it to 220. Okay. I'm going to send this to Confluent. Okay, and I've checked the Confluent. We're going to take the Confluent, the topics, and the policy is general. I look at the message and okay, yeah, here you go. This topic actually. So you see here in this, we received that the
250. Okay. Yeah, there is
250. Yeah, this is the update update. So to make this available, there are a bunch of processing happen behind the scenes. So now I'm going to ask the question: are you sure about that? Can you check again? So we're going to ask after we make the changes in the underlying policy, it updates the system. All right, so here you see 250. Sorry for the format. My Python format is not so good, but you see 250 in the chain, right? So you see here, even for the unstructured data like this, without a bunch of, for example, the re-embedding of the data coming from Confluent Kafka happened behind the scene, right? Before it get updated in our Azure search. So it is empowered by the real-time streaming from Confluent like this. So it is an example of how the even for the unstructured data on streaming can be done over here, right? So yeah, those are just like a few quick demo of the flight copilot for you, right? So everything from rebooking, checking the flight status, and see how it acts on real time, which is a really nice feature for any sort of real time scenarios. This is all the code behind the scene. Sorry, today I forgot to put in the Cosmos UI, and that's why it did not do the flight chain for me in my environment I set up. But you look at the code here, everything from check flight status function for the flights, right? These are the real kind of transaction that we interact with, underlying system, confirm flight change. This is Cosmos DB, everything here. And then this is the persona we define. And then over here, you see also the Azure function where we have the interaction. We listen to the event from Confluent, right? So all these are Confluent. This is a Confluent. This is Azure function triggered by Kafka Confluent. You see Kafka trigger, right? Confluent Cloud username, Confluent Cloud password, Bootstrap server.